All right, so we are plotting the complex numbers in the complex plane, and then we're finding the real part, the imaginary part, the modulus, and the principal argument of the point, or of the complex number. So the real part was square root of 3, the imaginary part was -1. We graph our point, it's in quadrant 4. The modulus is the square root of square root of 3 squared plus -1 squared, which gives us the square root of 4, which is 2. Then we need to find the argument, which is the angle. So to do that, we do the inverse tangent of b over a. Don't forget it's y over x. So theta is going to be the inverse tangent of -1 over square root of 3. So that would be a -π/6. Now that's the answer is -π/6 because the inverse tangent of negative square root of 3 over 3 is -π/6. But that is also the correct answer because we want a quadrant 4 angle that is between -π and +π, and that works. All right, moving on to question 2. So we're going to graph the point -2, +4, right? And we're going to find the real part. The real part of z is -2. The imaginary part of z is +4. The modulus of z, notice how it's just like an absolute value because it's the distance. Do you guys remember from the definition of absolute value is the distance of a number on the number line from 0? So this is basically what that is. It's the distance of a number, but instead of on a number line, it's in the plane. The distance of the complex number from 0, basically. So that's why we're using this absolute value notation for our modulus. So we have the square root of -2 squared, and -2 squared is the same as +2 squared, plus 4 squared. So that would be 4 plus 16, which is the square root of 20. And so that would be 2 square root 5 is our modulus. And then to find our arguments of z, we're going to find the inverse tangent of 4 over -2, which is the inverse tangent of -2. Okay, so actually to find theta, don't we need to, since it's second quadrant, and this will give us a fourth quadrant angle, we need to actually, where are we? Theta needs to be pi plus that answer, correct? So on my paper, though, I wrote it as a +2. Why did I leave it as a +2? Is that because tangent is odd? I'm trying to figure out why I did this. I don't know. I'm really confused all of a sudden. Okay, so for some reason the book, that's what they've done. I understand. Okay, so it would be pi plus, if we want the official answer, should I use an arctangent instead? Just a second, Adrian. I can't write and answer at the same time. Okay, so we have y divided by x. So 4 divided by -2 is -2. That gives us a fourth quadrant angle. But in order to turn a fourth quadrant angle into a second quadrant angle, we need to add pi to it. So it's pi plus that answer to get this answer. However, the book has done this to it, so tell me what they did to get this answer instead. I'm not sure what the purpose of doing this is, but I say leave it the other way, but this is how the book lists it. Why are these two things the same? It's an odd function. Yeah, so the if that's negative, we can change it to positive and move the negative out here. Okay. So there's our answers for that one. All right, moving on. Do you want me to go through and highlight the answers at all? So we have the real, the imaginary, we have the modulus, we have the angle. We have the real, imaginary, modulus, and this whole thing right here is the angle, right? All right, number 3. So 3i would be 0 this way and up 3, so it's right there. So the real part is 0, and the imaginary part would be 3, and the modulus would be 3. How did I know that without calculating it? Yeah. Or it's just up 3. What's its distance from the origin? Yeah. Okay. So then we do the argument. So the argument of z is going to be the inverse tangent of, 3 over 0. We can't really do that, except we just know it's undefined. So what's tangent going to be if it's undefined? You can actually look at the angle on our graph. We should immediately know where it is just by looking at it. Yeah. So the argument is going to be at pi halves. Why not 3 pi halves? The tangent of 3 pi halves is also undefined. That means the point would go down. It would be a negative 3i instead of up, which is a positive 3i. Okay. Have you guys noticed this book likes to use the 117 for some weird reason? I don't know why. You know, the book, the committee I've been working with to write this book, they basically started with the framework of a different OER book that was written by someone else and then revising that. So some of the weird stuff, like the negative 117 stuff, just came from that original book. It's just weird. That's right. I don't know. Why would they keep doing problems about Sasquatches either? I don't know. Okay. So the real part, no, it's actually from the book that it's based on. So I think the authors of the original book that our book is being based on might live up in the Northwest where all the Sasquatch like stuff, rumors, urban legends are from. So anyway. Okay, so what's our modulus? So it's kind of like the last one where we have 0 squared and we have negative 117 squared. So that just gives us 117 for our modulus, right? So then we can look again, just look at our graph to figure out where that angle is. So our argument of z or theta is right. For some reason I was going to say negative pi, and then I remembered, oh yeah, if the answer is negative, if you're thinking the answer is negative pi, just change it to pi because that's the one that's included. Okay, pausing this video took way too long. Say